We started a new project in Mr. Kramer's class, which was the bottle flip project. We already knew what it was, but he brought math into the subject. And what we had to do is use real world skills through authenticity to shoot videos, edit it by adding songs, music, words through iMovie and Movie Maker.
Thank you, Blake. My name's Foom, and I'm going to talk about how our project was academically rigorous. We use measures of central tendency, which are means, median, modes, range, volumes, proportions, and probability. And our driving question for our project was, how can we as teenagers use math to create a viral bottle flip video?
Thanks, Foom, and thanks, Blake, and thanks to the rest of my students that decided to help out and share with everything for this video. One of the things I'm going to be talking about is how this project used applied learning and active exploration to reach our students and to hit those 6 A's. So one of the main things we did is every student was given 5 bottles. Every group was given 5 bottles, all the same size, and we filled them all up. We figured out what would be the best for landing a bottle flip. And so every group had every team member flip each bottle 10 times each, and they recorded that information in a data table. This is an example of what one of our data tables look like. So we have everybody's name. These were the different heights that we had put on the bottles. Then we converted those to milliliters, did our bottle flips, and collected all that data. From there, we did a benchmark where I checked to make sure all this was accurate. And then we moved on to mean, median, mode, and range. I asked the students as a group to decide what would give us the best results. They told me, and then they were to make a graph from that data. And you'll hear more about that later on whenever somebody else is up here talking. From the experiment, we took those results, gathered our results, and used those to apply what we had learned. So the way we applied that is we took our bottle, which was 153 milliliters, is what we found to be the best probability of landing is whenever it was filled up to 153 milliliters. We took that and used it to apply it to a different size water bottle. And so with that water bottle, we found proportions that made it equal to the 153 that also had the same exact probability to be able to land.
Thank you, Mr. Kramer. I'm Karen English, and I'm going to talk to you about how we use adult connections. We worked closely with Mr. King, who helped us with volumes and converting milliliters and accurately measuring these volumes, and he helped us discover how many milliliters should be in the water bottle.
Thanks, Kyron. My name is Brianna, and I'm going to go over the assessments part of the bottle flip project. At the beginning of the project, we received an entry document which let us know that our end product would be a video. The video at the end of the project was peer graded upon creativity, entertainment, and appropriateness. During the project, Mr. Kramer checked our work at different times. For example, once we completed our data tables, Mr. Kramer went over those just to make sure that we were on the right track. Then we had to choose appropriate graphs, in which he also went over for us, just to make sure that we had stayed on the right track as well as used the appropriate graphing methods.